All right, so this is a walkthrough on how to linearize the data from part 2 of the Simple Circuit Lab. I have some fake data up here that I made up, and I have LoggerPro open. You should have LoggerPro open. This is the walkthrough that takes you from the very beginning as if you have no data put in already. Some of you may have already put the data in, and if you have that, there should be another walkthrough that's a little bit shorter, so you don't have to watch this beginning part. So the first thing that you want to do, have your data out there, have LoggerPro open. If you don't have that, pause, get that done, and then come back and press play again. So here we are. What we want to do first is put our data into LoggerPro. So my data is over here. Our X value is going to be our independent variable, which is the resistance. So I'm going to put in 15 for my first resistor, and then my first current is 0.128. So just go ahead and put in, you should have 6 pieces of data. And it's either the data that you took yourself, or you can use the data from the Google Drive document that is done for you. Oops, 0. All right, I'm almost done. All right, if you don't have all your data in, go ahead and pause and then come back and see when you're ready. So the next thing we really want to do is double click on the column headings up here, because putting the information in here is going to help you in the long run. So I'm going to double click on the X, that's my resistance, and that's what I'm going to put in for the name. You could put, I guess, capital R and leave it there. I'm going to write resistance, RES, okay. And then for the short name, that's the variable that would be in a mathematical model. And the variable for resistance is R. And then the units for resistance are ohms. So if you come over here and click the drop-down menu and you go to Greek upper, the very last one on the bottom is the ohm symbol. You could write out OHMS if you'd like also. I don't know, I like the little friendly horseshoe with the feet. So, and then I'm going to hit done. I'm going to come over, double click on the Y column heading. Don't skip this step. And I'm going to put in current, which is our dependent variable. And then I'm going to put letter I, which is the variable you'd use in a mathematical model. And the units, what it's measured in, is capital letter A for amps or amperes. And then I'm going to click done. All right. So then we're going to come over and put a linear fit. A lot of times when you do this, it highlights all of the data. I usually click even though I don't really need to. But you do want to come over here, right click in the middle of the graph area. Go down to auto scale and then auto scale from 0 so that you can see all of your data. And then you're going to put a linear fit on it. And you could do that 2 ways. You could come over here and hover. There's a little R equals. And if you hover there, it'll say linear fit. Or you can go to the Analyze menu and go down to Linear Fit, whichever way you want. And then here's our values right here. When you put a line on it, though, automatically it should look a little odd, because if you look, the data looks like these red dots really look like they're curved. If you follow them, you can see a real curve, that it's curving like this. And it goes from over and then under, under, on over. So we're getting this curve right here. So what you want to do is we could run all of our statistics, but it's going to fail a lot of the statistics, and that's an indication that it needs to be linearized. But this one looks so much like a curve that I'm not even going to bother with my statistics. I'm just going to linearize it. So we want to open up or look at the blue sheet, and there should be a link at the top of the assignment, and it's the graphical method summary. Okay, it would be the blue sheet. And the first part is the graph shape, tells you what the relationship is in words, and then what you should do to modify the graph to linearize it, and then what it looks like in the algebraic representation with the X's and Y's and M's and B's. And you want to look for the shape. And a lot of people want to use the shape here, this one where you have a line with a negative slope. That's what the linear fit looks like. That's true. But the data looks like this one below it. It looks like it's curved like this. This is an inverse relationship. So this is what we want to look at. And it's telling us that y is inversely proportional to x, or as x increases, y decreases in a hyperbolic way. I think inversely proportional is a little simpler, easier to look at. And then this third column says what to do in order to linearize it. And it says you're going to replace x with 1 over x. So whatever's on the x-axis, we want to replace it with 1 divided by that. And we want to replace all of the numerical values. And we're going to have the LoggerPro equation do that for us. So the key here is that this tells us right here that we want to replace x with 1 over x. That's the key that you want to walk away from this blue sheet with. So going back to LoggerPro, x on my x-axis is resistance, and I want to replace that with 1 over resistance. And I could go and just make a new column, or even replace this column and rename it and just do 1 divided by each of these numbers. But it really is a lot easier to go up to the data menu, click on data, that's the 4th one over, and then you're going to go down to new calculated column. And so this means that you're going to have the computer do the work for you. And so we're going to click that, and this is the inverse resistance. So I'm going to write out inverse resistance, and the short name is going to be 1 divided by the resistance. So it's 1 divided by capital letter R, because resistance is that the variable for resistance is capital letter R. So inverse resistance would be 1 divided by that. And the units, same thing, resistance is measured in ohms, so the inverse resistance would be measured in 1 divided by, not clicked in there, oh, I put it over here, sorry. So I'm going to click in the units and do 1 divided by, and then I'm going to click on the drop-down menu. I'm going to go to the Greek uppercase, and then all the way to the bottom and pick the omega, or the ohms. And then we're almost done. We're going to come down to the expression box right here, click in here, and we want to do 1 divided by the resistance. So we're just going to do 1 divided by, and then we're going to have the computer do the work by telling the computer to find the variable column resistance. So I'm going to come over here and click on this center box right here. I click there and I choose resistance. So I'm telling the computer to take 1 divided by whatever number there is in this column of data and make a new column, inverse resistance, and put that number that you've calculated there. So that's all you have to do. You should have those little quotes. That all happens automatically, and then you're going to click done. So if I come here, I'm going to hit Control R to rearrange. Now you can see I have 3 columns of numbers, and this blue one here is the one that the computer did and did all the mathematical work for me. That really doesn't take that long. I know when you see the instructions written out, it looks a lot more complicated than it is. And then we want to replace resistance with 1 over the resistance. So I'm going to come down here where I see resistance. I'm going to left click, which is the regular click on it, and then I'm going to choose inverse resistance. And then all of the numbers, the data is over here. So I have to right click, auto scale from 0 again. And this is my old linear fit, so I'll just get rid of that. I'll try again. All right, and then I'm going to click another linear fit here. You can do it either way. And here is my linearized graph. And notice the mathematical model there, it says I is equal to mx plus b. When you use a linearized calculated column in the along the x-axis, for some reason, it will not replace the x with the 1 over r. And I don't know why LoggerPro does that. It just doesn't. So if I was to write this down, and maybe I should, let's go back to my data. And let me show you how I would do that. Here it is. So if I was to write that down, and this is a little awkward, so forgive me if my writing isn't very good, but if I was to write that down, I would be taking the I equals what's given to me. Wait, here we go. It says there I equals mx plus b. So instead of the x here, I'm going to put 1 over r. And so I'm going to do I equals, and then my slope, which is going to be 1.929 in my case, amps over 1 over ohms, which actually if you take and divide by a fraction, it's like you can invert and multiply, so that really is the same as amp ohms. And then, oops, I made it go away. Give myself some more room. That's my M. And then for my X, so that's this part right here, I did the M, but don't forget the X. This is something that a lot of people do. My X is going to be 1 divided by R, and then plus whatever your Y-intercept is, which mine is 0.0009861 amps, which I'm going to have to get some more room again. 0.000961 amps. But in the Canvas activity for today, really all you need to write down this value right here, 1.929 amp ohms, or amps over 1 over ohms. Either one of those is fine. And then you have to tell me what voltage you used, which is 2.0 volts. And so these two things would be the answers for today's activity, to give the linearized slope and the voltage that you held constant when you did your measurements. All right. If any of this isn't clear, if you have any questions, email me and I'll get back to you as soon as I can. All right. Bye.